Alright, in this video, we'll be talking about temperature and thermometer. Now, temperature is the degree of hotness or coldness of a body. It's a measure of the average kinetic energy of molecules in a substance. Alright, so that's what temperature is. Now, to measure temperature, we make use of an instrument known as the thermometer. Thermometer is a device used to measure the temperature. Now, every thermometer is made up of a substance known as the thermometric substance. Very, very important. All thermometers have a substance known as the thermometric substance. So, what then is the thermometric substance? Now, the thermometric substance or substances are substances that have some physical property. All right, they are substances that have some physical property, okay, which changes continuously as temperature changes. Thermometric substances are substances that have some physical property which changes as temperature changes. Now, the thermometric substance depends on the type of thermometer. Different thermometer have different type of thermometric substance. So now we are going to be looking at a table of the thermometers and then their thermometric substances. Now, the first one here we have is liquid in glass thermometer. Thermometric substance found in a liquid in glass thermometer is mercury or alcohol. And then what's the physical property that changes? We have volume or height of liquid. All right, do not forget we said thermometric substances are substances which have some physical property that changes alongside a change in temperature. All right, substances that have physical properties that can change whenever there is a change in temperature. Now, mercury or alcohol is a type of thermometric substance found in the liquid and glass thermometer. So since mercury or alcohol are both thermometric substances, it simply means they possess properties that change whenever there's a change in temperature. And what's the property that change? We have the volume or height of liquid. So that liquid which changes, all right, in height or volume is what we referred to as the thermometric substance. Its ability to change whenever there's a change in temperature is what makes it a thermometric substance. Now, other types of thermometer have their own thermometric substance. For instance, we have the gas thermometer. Thermometric substance is the gas. The physical property that changes whenever there's a change in temperature is the gas pressure. We also have the resistance thermometer. Thermometric substance is the resistance wire. Physical property that changes whenever there's a change in temperature is electrical resistance. We also have the thermocouple. All right, thermometric substance found in thermocouple, we have two dissimilar metals. All right, two dissimilar metals. All right, example, we have the copper constantine combination. All right, this is a thermometric substance. Now, the physical property that changes here is the EMF. All right, so this is basically what thermometric substance or thermometric substances are all about. Now, we also have the fixed temperature and temperature scales of thermometer. Each thermometer has two fixed points called the upper fixed point and the lower fixed point. The upper fixed point is the temperature of steam from pure water boiling at standard atmospheric pressure of 760 millimeter mercury. The temperature of steam from pure water boiling at standard atmospheric pressure of 760 millimeter mercury is what we refer to as the upper fixed point. And then the lower fixed point is the temperature of pure melting ice. Temperature of pure melting ice at standard atmospheric pressure of 760 millimeter mercury. The lower fixed point is the temperature of pure melting ice at standard atmospheric pressure of 760 millimeter mercury. Now, the difference in temperature between these 2 points, that's the upper fixed point and lower fixed point, is known as the fundamental interval. The difference between the upper fixed point and lower fixed point is what we call fundamental interval. Now, there are three types of scales in current use. We have the Celsius scale, the Fahrenheit scale, and the absolute or Kelvin or thermodynamic scale. All right. Now, let's start with the first one. This is the Celsius scale. The upper fixed point for Celsius scale is 100 degrees Celsius. The lower fixed point is 0 degrees Celsius. The difference between the upper fixed point and the lower fixed point gives us the fundamental interval. For the Fahrenheit scale, the upper fixed point is 212 degrees Fahrenheit. The lower fixed point is 32 degrees Fahrenheit. The difference between upper fixed point and lower fixed point is what we call the fundamental interval. The same thing here for the Kelvin scale. Upper fixed point is 373 Kelvin, lower fixed point is 273 Kelvin. The difference between these two gives us our fundamental interval. Now note, in scientific works today, two types of temperature scales are usually cited, and that is the Celsius scale of temperature and the thermodynamic scale of temperature. Alright, two types of temperature scales are usually cited. We have the Celsius scale and the thermodynamic scale of temperature. Now the first one, the Celsius scale. The Celsius scale is defined by the equation theta over 100 equals x theta minus x naught all over x 100 minus x naught. Now theta here stands for the unknown temperature. We can use this to calculate the unknown temperature. Alright, unknown temperature at a particular value of thermometric property. Alright, so theta is the unknown temperature. X theta is the value of thermometric property at unknown temperature. Alright, X stands for our thermometric property. It can be length like the liquid in glass thermometer, it can be pressure like the gas thermometer, it can be EMF like the thermocouple, it can be resistance, electrical resistance like the resistance thermometer. Alright, so it all depends. Our value of X depends on the type of thermometer we're talking about. But do not forget, theta is the unknown temperature. 100 is a constant. X theta is the value of thermometric property at unknown temperature. X naught is the value of thermometric property at 0 degrees Celsius. X 100 value of thermometric property at 100 degrees Celsius. So like I said, the value of X depends on the type of thermometer. For instance, in a liquid in glass thermometer, we have theta over 100, L theta minus L0, 100, L naught all over L 100 minus L naught, where L is the length of the liquid thread, be it mercury or alcohol, the length or the height or the volume. Alright, L is the thermometric property in this case for a liquid in glass thermometer. And then for a gas thermometer, P being pressure, alright, is the thermometric property we're talking about. So P will be the pressure at P theta will be pressure at unknown temperature. Theta is still unknown temperature. P naught will be pressure at 0 degrees Celsius. P 100 will be pressure at 100 degrees Celsius. For resistance thermometer, the same thing. Theta over 100. In this case, our electrical resistance is now the thermometric property. So we are going to have R theta minus R naught all over R 100 minus R naught. R theta is the resistance at unknown temperature. R naught is the resistance at 0 degrees Celsius. R 100 is the resistance at 100 degrees Celsius. And therefore, a thermocouple, theta over 100 equals E theta minus E naught all over E 100 minus E naught. E theta is the EMF at unknown temperature. E naught is EMF at 0 degrees Celsius, and E 100 is EMF at 100 degrees Celsius. Now looking at this example here, they said given the length of mercury thread of liquid in glass thermometer at ice points, alright, in this case we are talking about a liquid in glass thermometer, so we'll be making use of this equation. Our X now is going to become L. So they said given that the length of mercury thread of liquid in glass thermometer at ice point and steam point, alright, ice point and steam point are 3 cm and 23 cm respectively. So it simply means ice point is 3, steam point is 23. Ice point is what we refer to as 0 degrees Celsius, and steam point is 100 degrees Celsius. So now they say given that the length, so we have L, length of mercury thread in liquid in glass thermometer at ice point. At ice point we write as L0. Alright, L0 is 3 cm, and steam point L100 is 23 cm respectively. They say determine the temperature, or known temperature is what we are looking for. Determine the temperature reading when the length is 18 cm. So the length at the unknown temperature was given also 18 cm. So how do we go about this question? Like we can see here, this is about length of liquid in glass thermometer. So we'll make use of this equation here. Alright, so we'll go straight to our equation, which says theta over 100 equals L theta minus L naught all over L 100 all over minus L naught. Alright, so theta here being the unknown temperature all over 100 equals L theta, that's the length at the unknown temperature, is 18. So we have 18 minus L naught, which is 3, all over L 100, which is 23, minus L naught, which is 3. And that will give us theta over 100. We're going to have theta over 100 equals 18 minus 3 being 15 all over 23 minus 3, which is 20. So now we can cross multiply. 20 times theta being 20 theta equals 15 times 100. Alright, so to get the unknown temperature, divide both sides by 20. So we have theta to be 15 by 100 all over 20. Alright, and that will give us our unknown temperature to be equal to 15 times 100 all over 20, which is 75 degrees Celsius. Alright, so this is our answer in degrees Celsius. This will always give you, the Celsius scale will always give you answer in degrees Celsius. So now all your options, if you observe, are in Kelvin. So we need to convert this to Kelvin. To convert it to Kelvin, we'll simply add 273 to this. So we have theta to be 75 plus 273. Alright, and that will give us, we have 75 plus 273, and that will give us 348 Kelvin. So our unknown temperature is 348 Kelvin, option C. Now the next thing we are going to be looking at is the thermodynamic temperature scale. The thermodynamic temperature scale measured in Kelvin, Celsius scale measured in Celsius, alright, like we looked at previously. Now the thermodynamic temperature scale measured in Kelvin is one, alright, is one that uses only one fixed point known as the triple point of water. A triple point of water is a fixed point for the thermodynamic temperature scale. Now the triple point of water is the temperature at which melting ice, pure water, and saturated water vapor coexist in equilibrium. The temperature at which melting ice, pure water, and saturated water vapor coexist in equilibrium, it is equal to 273.16 Kelvin. Alright, this is the triple point of water. Alright, I'll take it again. Triple point of water is the temperature at which melting ice, pure water, and saturated water vapor coexist in equilibrium, and it is equal to this. This is the value for it. Alright, now the thermodynamic temperature scale is defined by the equation. Just like we have the Celsius scale being defined by an equation, we also have the thermodynamic temperature scale being defined by an equation, which is this. Alright, and here we have our unknown temperature T equals 273.16 xt. Alright, that's the value of thermometric property at unknown temperature, that's xt, and then xtri, value of thermometric property at triple point of water. If you see it here, we have T equals 273.16 xt all over xtri. T is the unknown temperature, xt is the value of unknown property at xt is value of thermometric property at unknown temperature, xtri is value of thermometric property at triple points of water. Now for liquid in glass thermometer, we have T equals 273.16 LT all over LTRI. L is the length, alright, of the liquid. Alright, remember for liquid in glass thermometer, the thermometric property is length. Alright, X, as you can see, or like we looked at previously, usually represents the value of thermometric property, and it depends on the type of thermometer you're looking at. So for a liquid in glass thermometer, the thermometric property is length. Alright, so that's why our formula is going to be 273.16 LT all over LTRI. For a gas thermometer, The thermometric property is pressure. So that's why our formula is no longer going to be xt over xtri, but pt over ptri. So we have unknown temperature equals 273.16 pt all over ptri. For a resistance thermometer, we're going to have unknown temperature equals 273.16 RT all over RTRI. Alright. Resistance is not the thermometric property, so we're going to have R in place of X. Now for a thermocouple, the thermometric property is EMF. So in place of X, we're going to have E. Alright. So rather than writing T equals 273.16 XT all over XTRI, we're going to have T equals 273.16 ET all over ETRI, where E is the EMF at unknown temperature, ET is EMF at unknown temperature, ETRI is EMF at triple point of water. Here we have RT in place of X. For a resistance thermometer, we're going to have R. So R is going to be the resistance at unknown temperature. This is going to be resistance at triple point of water. And then here we're going to have pressure at unknown temperature, and this is now going to be pressure at triple point of water. That's for a gas thermometer. And then for liquid in glass thermometer, in place of length, in place of X rather, we're going to have length, which is length at unknown temperature all over length at triple point of water. Please, all these equations are very important, or you can just take note of the general form. All right, for liquid in glass thermometer, in place of X, you have L. For gas thermometer, in place of X, you have P, pressure. All right, P, T, and PTRI. And then for a resistance thermometer, you're going to have RT all over RTRI. For a thermocouple, you're going to have ET all over ETRI. It all depends on the type of thermometer. So looking at this question, they said determine the thermodynamic temperature at the pressure of 850 millimeter mercury. Determine the thermodynamic temperature. So we are looking for the unknown temperature. All right, at the pressure of 850 millimeter mercury. We are looking for the thermodynamic temperature at the pressure of 850 millimeter mercury. So pressure at unknown temperature, all right, is 850 millimeter mercury. And triple point of water pressure of 760 millimeter mercury. So pressure at triple point of water is 760 millimeter mercury. All right, so this obviously is a gas thermometer. So our equation now is going to be this one, unknown temperature. So we'll just come down here, we'll say unknown temperature equals 273.16 pt, pressure at unknown temperature, all over pressure at triple point of water. If we simplify, we're going to have unknown temperature equals, plug in our values, we have 273.16 times pt, pressure at unknown temperature, which is 850, all over pressure at triple point of water, which is 760. And that will give you unknown temperature to be equal to, we use our calculator now to simplify this. We're going to have 273.16 times 850 all over 760. And that will give us 305.51 Kelvin. Don't forget, the thermodynamic temperature scale usually measures temperature in Kelvin, whereas that of Celsius scale will give you your answer in degrees Celsius. So this is our answer here. T equals 305.51 Kelvin, which is option A. Alright, so we've come to the end of this video. So please do well to subscribe to this channel and also like the video and share to your friends.